Hello everyone, welcome to India's largest e-learning platform Gradeup. कैसे हो आप लोग? बताओ सब लोग कौन कौन आ गया? Mark your attendance. Tell me who has come. So guys, till yesterday we have done the power system, right? And Ricky has saying that sir, please provide the PDF. Okay, beta, I will provide the PDF for the power system too. After this lecture, I will upload the PDF on the same video that you are asking. Right, so let's start our today's class, and today's class is going to be one of the most important subject of your electrical engineering, which is a power electronics. Okay, बहुत ही अच्छा subject है, interesting subject है, and important भी है for your different exam, especially for the Vizag exam. Okay, hello Surendra, hi Bablu. Okay, so power system, I hope you have understand some few concepts in a power system that I have taken 2 classes earlier. Now I'm going to take 2 classes on power electronics, and we will try to cover more than 70 questions in upcoming 2 classes today and tomorrow. Hello Alka. So let me introduce myself. If you are watching me first time, my name is Ishaan Mudgal. I have a 3+ year of experience, 5 times GATE qualified, MTech gold medalist from NIT Allahabad, and these are my area of expertise. And guys, if you want a crash course for a power electronics for a GATE exam, follow our other YouTube channel, which is specially created for electrical and EC students. And there I have already taken the crash course on a power electronics. So by spending 9 to 10 hours, you can revise your power electronics very easily. You can follow my that question also. बेटा digital electronics का video बेटा that we are also planning, that we will bring very soon. Okay, so first question. So everyone try this question. And give me the answer. So we will start our today's class with easy question, then we'll increase our level one by one. So the snubber circuit is used in a thyristor circuit for what? Why we use the snubber circuit in thyristor circuits? Tell me why we use the snubber in case of a thyristor circuit. And to understand this question, to give the answer for this question, you should know what is the meaning of snubber circuit. So think about it. Okay, Bablu has given the answer, dV by dt protection. Okay, anyone else? Okay, Abjil, Santosh, Priyam has given the same answer. Right, correct. The answer is dV by dt protection. See beta, what happened when you turn on the thyristor? See, to turning on the thyristor, you have many procedure. First procedure is a gate triggering. Second procedure is to increase the forward voltage. Third procedure is to increase the temperature. Fourth, by emitting a light. So we have many procedure to turn on a particular thyristor. So whenever a thyristor will turn on, one of the important point we should understand that let us suppose this is a load. Okay, and this is a thyristor, and here I have some supply. Vs. So if you turn on the thyristor without providing any protection, then what will happen? Across the thyristor, the rate of change of voltage will become very high. Why? Because if a load contain inductor, then you should understand at the starting or at the steady state, load will act like a short circuit. So what will happen? The voltage across the thyristor will become changed in a less amount of time. So dV by dt become very high. To protect your thyristor from high dV by dt rating, we have to put a resistor in series with a capacitor across the thyristor, and this is known as the snubber circuit. So what will happen? As soon as you switch on the thyristor, the capacitor will start to charge slowly, and whatever be the voltage across the capacitor, that will come across the switch. So the switch will start, then the voltage across the switch will start to increase slowly. That's why dV by dt will get reduced. So this is a very important point for protection of your thyristor. So answer is dV by dt protection. Next question. it is a preferable to use a train of pulse of high frequency for a gate triggering of SCR in order to reduce. Why we use the train of pulse of high frequency for gate triggering of SCR? Think about it. Why we use? Everyone give the answer. Everyone give the answer. Okay. One of the important topic in power electronics, which is the turning on of a thyristor. How to turn on the thyristor. Okay. So to turn on the thyristor, one of the procedure is gate triggering. So one of the procedure is gate triggering. Okay, so Dhananjay has given the answer C. Bablu has given the answer C. Abjit given the answer C. Very correct. Very correct. What is the special advantage of using the high pulse gate triggering? The advantage is the size of a pulse transformer. It will reduce the size of a pulse transformer, and apart from it, apart from this particular advantage, the second advantage is that gate loss also decrease. Gate loss also decrease. What is the gate loss? Gate loss is nothing. When you are applying a particular signal at a gate, you have to provide some circuit. In a circuit, there will be a resistance, so there will be a loss in that particular resistance. So that will also reduce if you use the high frequency gate pulse. Okay, good. Next question. Which one of the following is not the advantage of a solid state switching of AC capacitor into AC supply over relay based switching? You know, in power system, if you have read about the protection in a power system, there are two type of protection we use. One is the relay protection and one is the solid state protection. In solid state protection, we use the power electronic devices. In solid state protection, we use the power electronic devices. So they are asking which one of these is not the advantage of power electronic devices. So indirectly they are asking which one of these is not a advantage of power electronic device. So everyone try this question. Think about it. Power electronic devices में कौन सी चीज नहीं होगी? First of all, power electronic device will have a long life. ठीक है? Power electronic device में long life होती है. That's why we are using a power electronic device extensively nowadays. Again, it has a fast response. Absolutely, it has a fast response. Low losses, yes, compared to your resistor, inductor and capacitor, which is going to use in relay. The power electronic devices has low losses. Low transient, that is not correct. In power electronic devices, the major disadvantage is that we have a high amount of transients. High amount of transients. Why? Because of a sudden switching in a power electronic device. Every power electronic device will act like a switch. Every power electronic device will act like a switch, and because of a switching, you will have a high transients. You will have a high transient. So this is the disadvantage. So the answer is low transient. Remember, what is asking? Which is not the advantage of solid state. So low transient is not the advantage. In case of a power electronic devices, you have to face the high transients. Why? Because for a transient, two conditions must be satisfied. First of all, switching must be happen, and second, there must be L and C. Then L and C will be provided at a load, and switching will done by the power electronic devices. Okay. So only Mopuri has given the right answer. Okay. Hello. Hi Ramdesu. Hi Yashwant. Next question. A very good question. Very good question and very important question. And you will see this question has been asked in many exams earlier. Okay. So if I talk about this question has been asked in IES also. Okay. GATE also. Okay. And different AE exams also. Okay. Absolutely the values will be different, but the type of this question has been asked in different exams. So think about it. The latching current in a blow circuit is 4 milliampere. What will be the width of a gate pulse required to turn on the thyristor? And first of all, the question is incomplete. The minimum width of a gate pulse. The minimum width of a gate pulse required to turn on the thyristor. So think about this question, everyone, and give the answer for this. Give the answer for this question. To understand this question, first of all, you should know what is the meaning of latching current. Latching current. It is the minimum current. It is the minimum current is the minimum current after which gate pulse can be removed. After which gate pulse can be removed. It is a minimum anode current. Okay? Anode current, or you can say a switch current. So what is the latching current? See, what is the latching current? Whenever you provide a signal to a gate, a thyristor will turn on. Okay, thyristor will turn on and it will allow some current to pass. Let us suppose that is IA. Now, when this current reaches the IL, when this current reaches the magnitude equal to IL, then I can remove the gate pulse. Why should I remove the gate pulse? Because if you are not removing the gate pulse, then there will be other losses will coming at a gate circuit. So I have to remove the gate pulse. Now, if you are removing the gate pulse before the latching current, before the anode current reaching the latching current, if you remove the gate pulse, your thyristor will again turn off. But if you remove the gate pulse after the IA cross the latching current, then your thyristor will remain turn on and it will not get turn off. Got my point? So latching current क्या है? आपका एक थ्रेशोल्ड वैल्यू है. एनोड करंट को उसको क्रॉस करना होता है. अगर एनोड करंट उसको क्रॉस नहीं करा और आपने गेट पल्स को रिमूव कर दिया, your thyristor will get turn off. So how to solve this type of a question? First of all, you need to assume that that switch is turned on. The switch is turned on. Then what will be the inductor voltage? See very carefully. What will be the inductor voltage? The inductor voltage comes out to be 100 volt. Okay. Now from this I need to find out the equation of current. From this circuit I need to find out the equation of a current, and after finding the equation of current I will put this equation equal to the latching current, and from then I can find out the time. Okay. Yes, Yashwan, I will tell this difference about latching and holding in upcoming questions. Okay. So here you can see di by dt is equal to 100 divided by 0.1. So di by dt is equal to how much? 1000. Okay. Now I am talking about a latching current, right? So what will be the change in current? What I can convert this differential like this. Change in current divided by change in time like this. Now what is the change in current? Change in current is latching current minus initial current, which is 0. What is the change in time? The time to reach the latching current minus 0 instant is equal to 1000. Okay. So what will be the T? T will be latching current is how much? It is given is 4 milliampere. Okay. Divide by 1000. It comes out to be 4 into 10 raised to power minus 6, which is 4 microsecond. It means that the width of a gate pulse, the gate pulse will be like this. See very carefully. The gate pulse will be like this. So this width must be equal to this time. Otherwise, if the width is less than this time, अगर आपकी width इससे कम हुई, then what will happen? Your thyristor will not get turn on. So the minimum time for which the gate pulse must present, it is 4 microsecond. If it is present more than this, then it will be okay, because I need to find out the minimum width. Okay. So when I didn't mention the minimum, in that case the answer was 6 and 4 both. But if they are mentioning the minimum width, the answer is 4. It means your gate pulse must be equal to or greater than 4 microsecond, so that the latching current, so that your thyristor will not get turned off. Okay. Latching current exam के लिए बहुत important phenomena है. And what is the meaning of holding current? That I will tell you after 2 or 3 slides. Okay, good. So latching current used in a particular turn on during the turn on of a thyristor. Next question, everyone. Which one of the following statement is correct in transistor? The reverse saturation current ICO. ICO is what? Reverse saturation current. Which of these statements are correct? A very easy question if you have understand the analog properly. Okay, this question is basically come from the analog, but we are using a BJT thyristor in power electronics also. So for this subject also this question is important. Okay, good. Priyam has given the, Vanil has given the right answer, Bablu has given the right answer. Absolutely correct. Remember beta, the reverse saturation current doubles for every 10 degrees Celsius rise in a temperature. Okay, and this question can also come in this form. For example, it is given that ICO is 2 milliampere. Okay, 2 milliampere at 60 degrees Celsius. Now they can ask to find to find ICO at 100 degrees Celsius. Okay, so this question can also ask in this form. Remember this thing. So you can see what is the rise in temperature. 40 degrees Celsius temperature has been rise. So according to that, your ICO will also increase. And this type of question has been asked earlier. So do this question in homework and give the answer in a comment section. That what will happen if I increase the temperature to 100 degrees Celsius. Good. Now here you will see the meaning of holding current. Everyone, which one of the following statement is correct in a thyristor? The holding current IH is sorry. So first of all, I will create the IV characteristic of a thyristor for you. I will create a IV characteristic of a thyristor. Okay, thyristor and SCR both are same thing. Okay, remember this point. Correct, Anmol. Sorry, Abjit. Sorry, correct, Abjit. So guys, this is the IV characteristic. This is the IV characteristic. Okay. Now, this is the IV characteristic of thyristor. So what are the different region in this IV characteristic that you should know very carefully? First of all, this is the reverse blocking. This is the reverse blocking mode. Reverse blocking mode means when your thyristor is reverse biased. Okay. Now, when your thyristor is in forward bias, one thing you should know, a SCR can block the voltage when it is forward biased. So in forward bias, SCR can act like a forward blocking mode. But remember, in case of diode के case में क्या होता है? When your diode is forward biased, it get turned on suddenly, but it does not happen in case of SCR. A SCR will block the some amount of voltage, and if you provide the gate pulse, then this is the forward conduction mode. Then this comes in a forward conduction mode. And if you don't provide the gate pulse, your thyristor will remain turned off. But if you increase the voltage, if you keep on increasing the voltage, then there will be one voltage which is the maximum voltage, after which your thyristor will turn on automatically. You need not require a gate pulse. But we never turn on thyristor by increasing the voltage. Why? Because it will block the reverse capability of a thyristor. So all the important points that I am explaining you, extra points I am explaining you, you should listen these points very carefully, and MCQ can form from any of these points. Okay. Now we are talking about a latching current. So I told you latching current plays a role during the turn on. So latching current is a current at which after which you can remove the gate pulse and your thyristor will remain turn on. Now during the turn off, when you are going to turn off the thyristor, how to turn off a switch? To turning off a switch, first of all you have to reduce the anode current. Somehow you need to reduce the current which is passing through the switch. Now when you keep on reducing the current, there will be a one threshold value, one limit. The limit is holding current, that when you reduce the current below the holding current, then your thyristor is turned off. Okay. So what is the holding current? It is IH. It is the minimum current. It is the minimum current below which thyristor turn off. जिसके नीचे जाके thyristor turn off हो जाएगा. Remember, if your anode current become less than the holding current, then your thyristor will turn off. So to turn off the thyristor, I need to use two conditions. To turn off the thyristor, remember this thing, this can ask in your exam. To turn off the thyristor, I need to follow two conditions. First, anode current must be less than holding current, and second, reverse voltage applied across switch. Reverse voltage apply across switch. If these two conditions are satisfied, then your thyristor can be turned on. And one more important point, these two conditions must be satisfied at the same time. It must not happen that reverse voltage is applying some another time. Anode current is less than holding current at another time. These two conditions must be satisfied simultaneously. Then your thyristor will get turn off. Otherwise, it will not get turn off. Okay. Now, theoretically, we put holding current equal to 0. It means when your anode current become less than 0, or you can say direction is about to change of anode current, then you can turn off the thyristor. But practically it's not the 0, it is greater than 0. And you can see in a graph, holding current is less than the latching current. The answer is this. And one more important relation, IL is 2 to 2.5 times of holding current. Okay. But remember, these conditions are very important. These conditions are very, very important. That to turn off the thyristor, your anode current must be less than holding current and reverse voltage applied across the switch. And both must be at the same time. Next. Sorry. Next question. Everyone, try this question and give me the answer. And guys, like the session and share the session with your friends. I can see that more people are live, but the session are liked by less people. Everyone like the session. That is your attendance. Which one of the following statement is not correct for a MOSFET? इसमें से कौन सी statement MOSFET के लिए सही नहीं है? Okay. First of all, these are easy to parallel is not correct. Remember, which statement is not correct? Okay, Nemo has said the option D. Okay, fine. Anyone else? Everyone try this question, think about it and give me the answer. I will tell you what is the right answer. And Priyam and Bablu and Ganpati is saying the option D. Okay, okay. Think about it, guys. Think about it. Okay, everyone give the answer. Okay, B, not 3 times. Beta, what is 3 times? हाँ, sometime it range. क्या होता है? Range ना 2 से 3 हमारी move हो सकती है, right? So range is not that much important. Range is not that much important, but it is according to application. If you are using a high rated thyristor, then the range is 3. But I'm talking about a general thing. Okay. 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 Everyone has given the answer. Let me give you the solution for this. Question is, which one of the following is not the characteristic? It means out of these 4, 3 will be the correct for MOSFET. So we will start with the first option. MOSFET are easy to parallel for high current. Okay, the answer is correct. Yes, when there will be a high current, you can use the MOSFET in a parallel range. You cannot use the diode in case of a parallel. Why? Because first of all, diode cannot handle the higher amount of current. Okay, or even the SCR. MOSFET can handle the higher amount of current. Next, leakage current is relatively high. It is one of the disadvantage. But for a MOSFET, it is true that leakage current is high. The option overload and peak current handling capacity are high. Beta, this is also correct. That's why we use the MOSFET in switching, because it can handle the peak current and overload current. If it cannot handle this type of currents, then you cannot use them in a switch. For example, think about it. If you know about the inverter, in inverter we use the MOSFET. And when you using the inverter, at that time there will be a high amount of current which flows, and your MOSFET can handle that high amount of current and peak current. But which is the wrong statement? This one. Have more linear characteristic. This is wrong. If you know the characteristic of MOSFET that you have read in analog subject, it is a more non-linear characteristic. Okay, it's not a linear characteristic. Why? Remember the characteristic in case of a MOSFET, it's something like this. If you remember, the forward characteristic of a MOSFET is something like this. Okay, it's not a linear characteristic, it is a non-linear device. It will have a non-linear characteristic. Okay, hello Mayur, I am fine beta, how are you? Okay, Albert Anthony C, yes beta, only Albert Anthony has given the right answer. Priyam, it is a voltage control device. Yes beta, it is a voltage control device. Why? When the gate voltage, gate to source voltage is greater than threshold voltage, then your MOSFET will on, and if it is not greater than threshold voltage, your MOSFET will be off. So it is a voltage control device. BJT is a current control device. Okay, now Yashwant is asking the thermal runaway transistor. Okay, that I will tell you. Meanwhile, everyone solve this question. Meanwhile, everyone solve this question. It is diode actually. It is a diode. Okay, thermal runaway क्या होता है बेटा? Thermal runaway is a very simple concept. Okay, I am not talking about transistor. In general, I will tell you that you can link with the transistor. See what happened. Assume that electron is flowing. Okay, if the electron is flowing in some path, and then it will strike to an atom. It will strike to an atom. Okay, let's suppose it is striking to an atom. When it will striking to an atom, it will release its own electron. It will release its own electron. Then this electron is again going to strike some atom. This electron is again going to strike some atom, and it will also, and these atoms is these electrons will again increase the electrons. Now some of the electrons get recombined with the atom. You know, recombination and combination process happen all the time. So some of the electron will recombine, but most of the electron will leave the atom. Due to which, what happen, when the electrons are leaving, the more current will generate. Okay, more current will generate, and when the electrons are absorbing, the current amount is decreasing. If the more current will generate, due to this, high loss will occur. You know what is the formula of loss? I square R. And when the current will absorb, the loss will decrease. So and this cycle will repeat again and again. That's why a thermal runaway will happen in almost every device. Okay, but BJT is the more prominent for the thermal runaway. In MOSFET, there is not high chances of a thermal runaway. But this we are talking about the signal devices. When you come in a power devices or the power electronics, thermal runaway can be improved by providing the heat sink. We provide the heat sink so that this particular thermal runaway can be improved or removed. So answer given by everyone is D, and Avjit has given the option C. Okay, see beta, first of all, THD is given for the AC supply, and VRF, which is the voltage ripple factor, given for the DC side. So whenever you have a THD and you want input current of a rectifier is maximum 4. Remember, whenever you have to make the THD less, the input current must be maximum. And to reducing the THD, the only thing we can use is the capacitive filter. And to remove the VRF, voltage ripple factor, we have to use the inductive filter. Remember this point. Voltage ripple factor act at a DC side, THD act at a AC side. Okay. For improving the quality of AC, we use the capacitive filter. For improving the quality of DC, we use the inductive filter. Why? Because capacitor has a property that voltage remain constant. Not always constant. You can say high. If you use the high amount of capacitor, the voltage will not change that much frequently. Similarly, for inductor, it will not allow current to change suddenly. So it will also make the current constant. So the answer is single phase diode rectifier with capacitive load. Next. Sorry guys. आज मुझे खांसी हो रही है. In a thyristor control rectifier, the firing angle of thyristor is to be controlled in the range of thyristor control rectifier. Okay, it means we are using a thyristor simply. Okay, and they're asking what will be the firing angle for the thyristor to be controlled in the range of. Everyone think about it. What will be the answer? Mayur, not consistent if you have a high amount of capacitor. See beta, I is equal to C dV by dt. This is the equation. I equal to C dV by dt. This is the equation. when you use the dV by dt equal to I divided by C, if this capacitor is very high, then what will happen? Change in voltage will be very low, right? So for the high amount of capacitor, change in voltage will nearly equal to 0. Okay, Abjeet and has given the option B and everyone has given the option A. No beta, the answer is option B. Remember, do you solve, have you solved the question of rectifier? Yes or no? If you solve the question of rectifier, then think about it. You are playing with the firing angle both in a range of 0 to 90 and 90 to 80. Do you remember? Yes or no? For example, I'm taking the simple case. I'm taking the simple case of single phase half bridge rectifier. This is the source voltage. What is the single phase half bridge rectifier? Single phase half bridge rectifier will look like this. Single phase half bridge rectifier will look like this. And suppose you have a resistive load. Okay. So I will draw the waveform for two firing pulse. I will draw the waveform for two firing pulse. Let us suppose I am taking alpha equal to 75, which is less than 90. So if alpha equal to 75, it means the voltage waveform will start from here. Okay, and it will end here. Why it will end at pi? Why it will end at pi? Because you have a resistive load, and after that it will be 0. If you take alpha greater than 90, let us suppose I am taking alpha equal to 150, then what will happen? Alpha equal to 150 will lie somewhere here. So before alpha, there is no output voltage. Why? Because the switch will act like a open circuit, and after that it has some voltage till pi, and then it is 0. Pi, then it is 0. So the answer is 0 to 180. Okay, and one more important point, guys. This is just a revision class, so I am assuming that you know how to draw this waveform. That's why I just draw it very fast, because the exam is just 3 days. After 3 दिन के बाद ही आपका exam है, so I cannot explain how to draw waveform. But still, if you want to know how to draw waveform for rectifier, inverter, chopper, follow our second YouTube channel, which is Gate EE and EC Impulse. Follow this channel, and beta, last week I have taken many classes on power electronics, and there I explained very carefully and very deeply how to draw the waveform and how to remember the formulas. Okay, there are many formulas in power electronics. You have an output voltage formula, RMS formula, and much more. So that I have already explained through 7 classes in this particular channel. So follow this channel and see those videos. Next, a converter which can operate both in a 3 pulse and 6 pulse mode is. So out of these 4 converter, which can operate in a 3 pulse and 6 pulse mode? Everyone. And power electronics is a subject which is very important, and which will be very easy if you follow the waveform. If you are trying to remember the formula, then this is my guarantee. First of all, you can't remember all the formulas. Second, if you remember the formula, you can't apply those formula. And third, if you are trying to remember the formula, you will not enjoy the subject. And if you are not enjoying the subject, you will leave the question of that subject in exam. Even though the question will be very easy, but through the statement, you will feel the question will be difficult. So if you want to study the power electronics properly, follow our that channel and see my videos. Even on a Gradeup app, I have taken many classes on power electronics. So on a Gradeup app, follow me and you can see those videos also. So Yashwant has said the option C. Mohipuri has said the option C. Correct. The answer is 3-phase semi-converter. See, one phase full converter can use as a 2-pulse rectifier. 2-pulse rectifier. Why? Because it's had only activate in both the cycle. Okay? For a 3-phase half wave converter, it is a 3-pulse rectifier. A 3-phase full converter is a 6-pulse rectifier. Now, what is 3-phase semi-converter? The diagram of a 3-phase semi-converter is like this. 3-phase semi-converter diagram is like this. So I'm drawing the diagram like this. Okay. So in 3-phase semi-converter, you have a 3 thyristor, 3 diode and a load. You have a 3 thyristor, 3 diode and a load like this. एंड व्हाट इज द सेमी कन्वर्टर्स, तो इसके लिए भी मैंने वीडियो अपलोड कर रखी है इन आवर अनदर चैनल. Okay, this is the three-phase semi-converter. Now what will happen here? If alpha is less than 60, if alpha is less than 60, this converter will behave like a 3-pulse converter. 3-pulse converter. If alpha is greater than 60, then this will act like a 6-pulse converter. So remember this point. This question they can ask in two ways. They can ask you the range of alpha, for which it is a 3-pulse or 6-pulse, or in this way they can also ask. Okay, Albert is saying signal system crash course is available. Yes beta, follow that channel, follow that channel. If I'm not wrong, Chandan sir is taking the signal system class. Okay, if I'm not wrong. Okay, so many subjects are going on that particular channel. I have already taken the power electronics. Right now power system is taken by the Ashutosh sir, network theory is taken by the Sanjay sir, and analog is analog या फिर EDC for EC students. Analog or EDC has been already taken by Sanjay sir, and digital is going on by the Chandan sir. So many classes are going on that particular channel, and that is basically focused on a crash course. So follow that channel. Next, the circulating current inductor is required in a dual converter too. Why we require a circulating current inductor in a dual converter? What is a dual converter? Does anyone knows? Does anyone knows what is a dual converter? किसी को पता है क्या होता है इसका मतलब? Yes, Mayur has said that right thing. Search Chandan sir name on that particular channel. You can see their videos. They have already taken the signal system. Okay, option B has given by the smoothen the waveform of the circulating current. Okay. Option C is given by Atul and Bablu, and option C is given by again Bablu. And everyone, think about it. Think about it. Now, first of all, to answer this question, you need to understand what is the dual converter, what is the meaning of circulating current. If you don't know these two topics, then you cannot give answer for this question, and you have to leave the answer. You have to leave the question in exam. So first of all, I will tell you what is a dual converter. A dual converter is a converter which is acting like a rectifier, and it will act like a inverter. Okay, a dual converter is a converter which can act like both rectifier and both inverter. What will happen in a dual converter? See, in a dual converter, if I am talking about a load, one side of a load is connected to a full bridge rectifier like this, and the another side of a load is also connected by a full bridge rectifier, but in reverse direction. Okay, like this. This is a supply here. This is a supply here. So this is the dual converter. So when alpha, this all are Thyristor. So for these Thyristor, let us suppose alpha is alpha 1. For these Thyristor, let us suppose alpha is alpha 2. Okay. Now for a dual converter, it is very important that alpha 1 plus alpha 2 must be equal to 180. इसका मतलब क्या हुआ? That if alpha 1 is less than 90, then alpha 2 is greater than 90. And whenever the alpha is less than 90, it will act like a rectifier. And whenever a alpha is greater than 90, the network will act like a inverter. So what will happen, guys? Both converters in this whole circuit of a dual converter, if alpha 1 is less than 90, then this side will act like a rectifier. If alpha 2 is greater than 90, this side will act like a inverter. Okay, remember this point. Now, what is the circulating current? Now, circulating current is a current which flows in this path. See very carefully. If the current is flowing in this path, direction can be clockwise or anti-clockwise. Direction is not important. If the current is flowing in this Thyristor, means a lag of Thyristor of this side or lag of a Thyristor of this side, then this is the circulating current. Okay, and this circulating current is very dangerous. Why? Because if the circulating current flows in a thyristor, it will short circuit the thyristors and the whole lag will damage. The whole lag, this is the lag. This is the lag. The whole lag will damage. So I have to put an inductor here. I have to put an inductor here. I have to put an inductor here so that this circulating current can be reduced. This circulating current can be reduced to 0. So the answer is limit the circulating current. Why? Because if you have remembered the machine, circulating current is always unwanted. Circulating current is also created in case of a generators in subject machines. So it is always an unwanted current. So to remove the unwanted current, I have to use the inductor. स्मूथ करने का मतलब क्या हुआ? स्मूथ करने का मतलब तो ये हुआ that you want the circulating current and you are smoothing the circulating current so that you can use it. But a circulating current in any device is a dangerous thing, or it is not useful at all. We have to remove or limit the circulating current. So to limit the circulating current, I have to use the inductor. Got my point? Whenever you see the circulating current in a power electronics or in machines, always remember you have to remove that particular current. So in transformer also, if you remember, in transformer also, in a three-phase transformer, we are facing with this particular problem. Remember this point? Yes or no? Transformer में आपने पढ़ा है ये point? Yes or no? And guys, very important information for you. If you are going to join our Gradeup, so remember one point. Tomorrow is the last day for the discount. After that, our price is going to be increased. So एक बार मन लगा के अच्छे से पढ़ाई कर लो, उसके बाद एक अच्छी सी जॉब लेकर एंजॉय करो अपनी लाइफ को. ये नहीं कि आप 2-3 साल तक पढ़ाई कर रहे हो और आपका कोई एग्जाम पास नहीं हो रहा है. Just why? Because you are not studying in a structure format. See, crash course is very advantageous for those students who have already understood the topic. But if you are not understanding the topics at all, you have to study in a structure format. So for a structure format, you can join our Gradeup. And for different students, we have a different batches. So for example, for the students who are going to focus more on a theory, we have a Gradeup batch. For the students who are going to improve their rank, we have a rank up gate. In this, numerical will be more. And this is the new batch that we have started, which is the Vision 2022. So it is for those students who are going to give GATE exam or ESE exam in 2022, and it is ideal for the second and third year students. For more information about any batch, we also have a batches of AE and JE. So for any information, you can contact on this number. Download our app also. Okay, and these are our star faculties in a electrical department. You can see the experience they have, so you can utilize their experience very well. And the last point, Gradeup Super. It is one of the most iconic thing that we have started, Gradeup Super. In this, first of all, you are getting a structured life courses that is very important for your preparation. And second, we will provide you the mock test also. And with the mock test, you know the advantage of mock test. You will feel the exam like questions, and if you can compare yourself with other students, you can also improve very well. Again, for more information, contact on this number. So let's again start our class. Everyone, now this question. In a single phase semi-converter with discontinuous conduction and extinction angle beta is less than pi, the freewheeling action take place for. Now to answer this question, you need to understand the meaning of freewheeling diode or freewheeling action. Extinction angle is the angle at which your voltage and current, basically your current becomes zero. Extinction angle is the angle at which your current becomes zero. Okay, remember this point. So some people have given the answer. Everyone try this question. And beta, don't forget to like the session. Everyone like the session. Okay, so Mayur has given the option D. Okay, Avjeet has given the option D. Correct. 0 degree, correct. See beta, very interesting question. And this question can come in your exam and you can confuse in this type of question. Why? See, very important point. what is the freewheeling action? First of all, freewheeling action will be performed by the freewheeling diode. It will be performed by the freewheeling diode. First of all, very important point, freewheeling action will be performed by the freewheeling diode. Okay? And now what is the freewheeling action? Whenever output voltage, whenever the output voltage become negative, then freewheeling diode will turn on. तब क्या होगा, आपका freewheeling diode turn on होगा, freewheeling diode will turn on and output voltage become 0 for that interval. मतलब क्या है, जब भी आपका आउटपुट वोल्टेज नेगेटिव की साइड जा रहा होगा तभी आपका क्या होगा, फ्रीव्हीलिंग डायोड काम करेगा और उस टाइम इंटरवल के लिए आपका जो आउटपुट वोल्टेज होगा वो 0 होगा. ओके, फॉर एग्जांपल I am taking a simple rectifier, a simple single phase half wave rectifier. Okay, like this. This is a single phase half wave rectifier. This is RL load. So see very carefully. See very carefully. I have a source voltage. This is my source voltage Vs. Okay. Now, what will happen? Let us suppose you fired the circuit. Let us suppose you fired the circuit at alpha. When you fire the circuit at alpha, so first of all, I will draw the waveform of output voltage. So output voltage is equal to source voltage till pi. We are talking about till pi. So output voltage will always equal to source voltage when the thyristor will on till pi. Now what will happen to current? Current को क्या होगा? Current will start to flow. Current will start to flow from the same point. Current will start to flow. Now whenever the load has inductor, one point you should understand very carefully, that current will increasing exponentially. Current will increase exponentially because you have inductor. Inductor has a property of energy storage element, so it will store the current. Okay, this is the current waveform. Now at pi what will happen? The polarity of this voltage is reversed. The polarity of source will reverse, and due to which this particular switch become the reverse biased. Lekin very important point, if this becomes switch off, then what will happen? The current will always reach to 0. अगर आपका स्विच बंद हो गया एकदम से तो आपका करंट एकदम से 0 पे आ जाएगा. But inductor has a property that current cannot change instantaneously. Inductor की प्रॉपर्टी क्या है? That current cannot change instantaneously. Current will discharge slowly. And due to the discharging of inductor, the switch is still on. Even the switch is reverse biased, but due to the discharging of an inductor, it will switch on. And because it is switch on, what will happen? The output voltage is still equal to source voltage until here. When the inductor current becomes 0, the output voltage will equal to the source voltage, and this angle is known as the beta, which is the extinction angle. Fine. Now what will happen if I applied a freewheeling diode here? So what will happen? This become the reverse biased. Okay, in a second half cycle. Now inductor have to discharge. Inductor को discharge होना ही होना है, but due to the freewheeling diode, inductor will discharge through diode. ना अब क्या करेगा? इंडक्टर डायोड के थ्रू डिस्चार्ज हो जाएगा. इट विल नॉट गेट एनी प्रॉब्लम टू अ थायरिस्टर, एंड थायरिस्टर अपने आप मेरा ऑफ हो जाएगा. सो व्हाट विल हैपन इन केस ऑफ अ फ्रीव्हीलिंग डायोड? द आउटपुट वोल्टेज विल स्टार्ट फ्रॉम अल्फा, रीच टू पाई एंड व्हेन द आउटपुट वोल्टेज बिकम नेगेटिव, उस पॉइंट पे आपका डायोड स्टार्ट हो जाएगा. And if the diode is start, what is the output voltage? It will be 0. Why? Because diode will act like a short circuit. तो यहां से लेकर यहां तक आपका आउटपुट वोल्टेज क्या हो गया? 0 हो गया. So remember always one point: a freewheeling diode can only operate if your output voltage is negative, and one point, if beta is greater than pi. If beta is greater than pi, then only your freewheeling diode will conduct. बिकॉज पाई के बाद ही तो आपका वोल्टेज नेगेटिव होना है, पाई से पहले तो आपका वोल्टेज नेगेटिव है ही नहीं. सो इफ बीटा इज लेस देन पाई, आउटपुट वोल्टेज इज ग्रेटर देन 0. आउटपुट वोल्टेज मेरा 0 से बड़ा है, आउटपुट वोल्टेज 0 से कम है ही नहीं पाई से पहले, तो इसका मतलब क्या है, फ्री व्हीलिंग डायोड मेरा काम ही नहीं करेगा. एंड इफ फ्री व्हीलिंग डायोड इज नॉट कंडक्टिंग, then the conduction angle is 0 degree. Otherwise, in a normal case, what will be the conduction angle? This much, which is beta minus pi. But beta is less than pi, it means output voltage negative ho hi nahi raha. And if output voltage is not going to negative, it means freewheeling diode will not work. So you can see this is just a 1 mark question, but you have to understand this question very carefully. Again, I am repeating myself. I just explained you this freewheeling diode in just 5 minutes, which is not fair. Okay, but I am assuming you have previous knowledge because exam is just 3 days later. If you want to understand this concept very carefully in depth, you should follow my videos on another channel. But remember that videos are in Hindi. Next question. Everyone try this question. When the firing angle alpha, this is alpha. When a firing angle alpha of a single phase fully controlled rectifier feeding circuit feeding constant DC current into the load is 30 degree, what is the displacement factor of the rectifier? Rectifier का displacement factor क्या होगा? Think about it. What is the displacement factor of a rectifier? Very simple. मेरे अकॉर्डिंग पावर इलेक्ट्रॉनिक्स का मोस्ट सिंपल क्वेश्चन है ये, एंड ये क्वेश्चन आपके गेट में भी पूछा गया है, पता है, गेट में, आईएएस में एंड डिफरेंट एई एग्जाम्स में, जबकि दिस इज द मोस्ट इजीएस्ट क्वेश्चन ऑफ अ पावर इलेक्ट्रॉनिक्स. नथिंग यू शुड वरी अबाउट. डिस्प्लेसमेंट फैक्टर इज इक्वल टू कॉस अल्फा. जस्ट दिस थिंग, just remember this thing, a displacement factor is equal to cos alpha. So alpha is what? Alpha is 30 degree. Answer is root 3 by 2. But this question has been asked many times. I don't know why, but this question has been asked many times in different exams. Next question. Good. Bablu, this answer is wrong, but yeah, आपके पहले का आंसर काफी सही थे. And Avjeet, correct answer. Mayur, correct answer. So next question. A fully controlled line commutated converter function as an inverter when firing angle alpha. So I told you one point अभी मैंने एक point बताया था आपको. If alpha is less than 90, it will act like a rectifier. Okay. If alpha is greater than 90, and obviously 90 से 180 तक ही जाएगा alpha, it will act like a inverter. Okay. But this is not the only condition. Why? Think about it. What is the inverter? Inverter is a device that converts DC into AC. Inverter is a device that converts DC into AC. So there must be a DC at the load side also now. If it is acting like an inverter, then at the load side there must be a DC. So the condition for an converter to act like an inverter is that first of all alpha must be greater than 90, and second, a DC must contain some battery. So the answer is what? 90 to 180 when there is a suitable DC source in a load, or 90 to 180 when it is supplied a back EMF load. This is the correct option. Option D बेटा, option D. जब back EMF का लोड होगा, back EMF का लोड होगा आपका, मींस कौन से लोड की बात कर रहा हूं मैं? RLE लोड की, और वी आर टॉकिंग अबाउट RE लोड. अगर ये दो लोड होंगे and alpha 90 से बड़ा होगा, then only your particular converter will act like an inverter. Otherwise वो converter inverter की तरह behave नहीं करेगा and output voltage आपका negative आ जाएगा. Just ये होगा. Good. So काफी लोगों ने C आंसर दिया है, but बेटा C is not the right answer. DC source, only DC source होने से फायदा नहीं होता, back EMF भी होना चाहिए. Okay. Next. Very easy question. Very easy question. If you know the formula, then the question is very easy. In a single phase full wave control bridge rectifier, minimum output voltage and maximum output voltage will be. So the formula of output voltage is 2 Vm by pi cos alpha. 2 Vm by pi cos alpha. Okay, either you can remember it or you should know how to derive this formula. But for the derivation, I am again telling you, follow the second channel. There I have explained all the derivations. Okay, so output voltage का formula क्या है? 2 Vm by pi cos alpha. For maximum for minimum output voltage, cos alpha must be minimum. Now cos alpha minimum will be where? Cos alpha minimum will be -1. Cos alpha minimum will be -1. So alpha will be what? Cos inverse -1, which is 180 degree. Right? Now for maximum, this must be cos alpha must be maximum, which is nothing but equal to 1. So alpha becomes 0 degree. Answer is option B. Correct. B and A. Correct. And this question has been asked in IES exam also. So guys, this is enough for today. I am giving you some questions for your homework. So just take the screenshot. Just take the screenshot. This is the homework question. This is the homework question. Take the screenshot, everyone. This is also a homework question. Take the screenshot. 2 question. And there's 2 more questions that I am going to give you. So just take the screenshot. Okay. Next, this is the homework question. For this, I will tell you solution tomorrow. But you should give the answer in a comment section. Everyone give the answer in a comment section as soon as you solve this question before tomorrow class. And this is also a homework question. To take 4 questions in your homework, and we will solve more questions tomorrow. So be on time on 10 p.m. Till then, bye-bye. Take care. I hope you like the lecture and you understand few points about the power electronics. But better again, power electronics को wave form से समझना. Don't try to remember the formula because there are many formulas you will see in a power electronics. Yashwant, on other channel the classes is in Hindi. But if you want classes in English also, I also took the classes in a Gradeup app. Download the Gradeup app. Follow me. Search me there, Ishaan Mudgal. Follow me and you can see my all the lectures on power electronics also. So I have also taken the classes of power electronics in English on a Gradeup app, and for Hindi on our another channel which is for the electrical and EC students. Okay guys, so bye bye, good night. And yes, Atul and Abjit has given the right answer for this question. Correct. So bye bye guys, take care.